So why are we dividing? Well, let's say you're trying to factor f of x equals 6x to the third minus 19x squared plus 16x minus 4. If you look at the graph, you'll notice that a 0 occurs at x equals 2, which means that x minus 2 is a factor of the function. You can factor out the x minus 2 using polynomial long division or synthetic division to get a simpler polynomial that will be easier to break down and find your final answers. All right, now this should be a review. We've done this before. You did it in Algebra 2. So here's how it works. We got basically 4 steps. The first step, and we're looking at dividing the problem we just talked about, is ask yourself, what is 6x to the third divided by x? Or another way of looking at it, what do I need to multiply x by in order to get 6x to the third? Then we're going to multiply that. That would be 6x squared. So we will multiply that by x minus 2 by the whole thing, not just the x, but the x minus 2. And then we're going to subtract. We're going to do 6x to the third minus 19x squared, which you see under the division sign, minus 6x to the third minus 12x squared, which is what we got from multiplying 6x squared by x minus 2. And then after we subtract that, we're going to bring down the 16x, the plus 16x, next to what we got after we subtracted, which was 7x squared. And then we're going to repeat that whole process. And so this is what it looks like. So you can follow the process. We got 6x squared. We multiply by x minus 2 and subtract it. Now be very careful with the subtraction. That's what throws most people off in this whole process. That gave us negative 7x squared. We brought down the plus 16x, and then we said, what do you multiply x by to get negative 7x squared? Well, that would be negative 7x. Multiply, so we get negative 7x squared plus 14x. Subtract and get 2x. Bring down the minus 4. And then finally, what do you multiply x minus 2 or x by to get 2x? You multiply it by 2. So multiply 2 times x minus 2, 2x minus 4, and when we subtract, we get a remainder of 0. Okay, so after doing that, what that tells us is that x minus 2 times 6x squared minus 7x plus 2 equals our original polynomial, equals 6x to the third minus 19x squared plus 16x minus 4. Now let's try this one. Now, again, we're going to go through the same process. We're going to say what times x gives us x squared. That's going to be x. We're going to multiply that times x plus 1, so we get x squared plus 1x. That will go underneath. And when we subtract, we're going to get 2x. We'll bring down the 5. X times what gives us 2x? 2. When we multiply, we'll get 2x plus 2. And when we subtract, as we see here, we have 3. And nothing left to bring down. Well, we have a remainder of 3, just like with regular division. And just like with regular division, we're going to write it as a fraction over the divisor. So it's going to be x plus 2 plus 3 over x plus 1. And this also tells us that x plus 1 is not a factor of x squared plus 3x plus 5 because it has a remainder. And factors must divide evenly. So in our previous example, the one we just did, we can tell that x squared plus 3x plus 5 is what you get when you multiply x plus 1 times x plus 2 and then add 3. Now, when we write it out like this, we're illustrating what is called the division algorithm. The division algorithm says if f of x and d of x are polynomials where d of x is not equal to 0, and the degree of d of x is less than or equal to the degree of f of x. In other words, the highest power of d of x is smaller than or equal to the highest power of the numerator of f of x, then there exist unique polynomials q of x and r of x such that f of x equals d of x times q of x plus r of x. Okay, translating that to the top of the slide here, f of x is the x squared plus 3x plus 5. That's our function. That's what we divided into. That was underneath the division symbol. equals d of x, that's our divisor, that's what went into the x squared plus 3x plus 5, that was the x plus 1, times q of x, that's your quotient, that's your solution to the division problem, that was the x plus 2, plus the remainder, which was the 3. So this is pretty much just saying that how we wrote that up at the top there, this is why we can do that, because of this division algorithm. A few things. Before you divide, you need to be sure to write the dividend and the divisor in descending order. Start with the highest power and work your way down. And if there are any powers that are missing, for example, if one of them goes from 2x squared to plus 3, well, you're missing an x term, and you need to put in a 0 for that. So from the highest power to all the way down to the end, if you are missing any powers, they should all be represented. You need to put in a 0 as a placeholder for that, and that goes for the dividend and the divisor. All right, so here are some examples. Why don't you pause the recording and give these a try, and then resume to check your answer. Okay, so see how you did. Follow the process. Okay, make sure, don't just check the answer. Make sure that if you didn't get it correct, that you go down through and find your mistake. And you need to be showing work on these. If you're not showing work, then I don't know what you're doing. I don't know how you're doing this without actually working them out. So make sure you show your work. Make sure it's neat so that you can read it, and on a test or quiz so that I can read it. And right now you should be checking that work if you missed anything to make sure that you understand it. Now we're also going to talk about synthetic division, and we did synthetic division last year. It is a shorthand way of doing polynomial division. And to use synthetic division, what we're going to do, first of all, in order to use it, the divisor must be x plus a number or x minus a number. There can be no powers and there can be no number in front of the x. The dividend itself must be in descending order. Of course, that needs to be true no matter what type of division you're doing. And again, any missing powers must be accounted for with zeros. And that's really, again, only going to apply to the dividend. Okay, so here's how we set up a synthetic division. Let's say we're going to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. First of all, notice there are no x's involved in this at all. We take them all out. Our x plus 3 is our divisor, so on the outside of our little half rectangle there, we wrote a minus 3. The minus 3 is the, notice that the sign is the opposite, and you always want to do that with that. You want the opposite sign there. Notice the top row is 1, 0, negative 10, negative 2, 4. These are the coefficients of x to the fourth minus 10x squared minus 2x plus 4. There is a 0 that is taking the place of the missing cubed term. X to the third is not there, so we have to put a 0 in its place. Now, to remind you of how to do this, what you're going to do is the first number, the 1, goes straight down. You don't do anything with it, you just drop it straight down. Then you multiply 1 times negative 3, and that gives you negative 3. You put the negative 3 under the 0, and then you add. 0 plus negative 3 is negative 3. Multiply negative 3 times negative 3, and we get 9, which goes under the negative 10. Negative 10 plus 9 is negative 1. Negative 1 times negative 3 is 3. That goes under the negative 2. Add, and we get 1. 1 times negative 3 is negative 3, which goes under the 4. 4 plus negative 3 is 1. Now we're done. The 1 is our remainder, but we got to put the x's back in now. And what you do is you start with the power that's 1 less than what you started with. So we started with an x to the fourth. Now we're going to put in an x to the third. So it's going to be x to the third minus 3x squared minus x plus 1 over x plus 3. Okay, so here are a bunch of practice problems. Why don't you pause the recording, try each of these, resume the recording to check your answer. Okay, so you see the process worked out here on all three of them. Again, you should be checking your answer, seeing if you missed anything. Remember that first number always comes straight down. You never do anything with it. Then you start the whole process of multiplying and then adding and multiplying and adding, and you do that all the way across until you're finished. Notice that in the second and third ones, we had to put in some zero placeholders. The negative x cubed, we had to put in a 0 for the x squared. And then on the last one, we had to put in 2 zeros because we were missing both an x squared and an x term, and you do have to account for both of those. Okay, the remainder theorem says if f of x, which is a polynomial, is divided by x minus k, the remainder will be f of k. In other words, the remainder you get by dividing the polynomial by a factor is the same as what you get if you substitute k in for x in the polynomial and solve. So this kind of gives you a couple of things that you can do with this. This lets you solve a polynomial for a given x by using synthetic division, so you could actually use synthetic division and the remainder would be the answer, or you can use it to determine whether or not you're going to have a remainder before you actually divide. And the advantage of that leads us to the factor theorem. The factor theorem says that a polynomial f of x has a factor x minus k if and only if f of k equals 0. So we can check to see if something is a factor of a polynomial before dividing it, which could save us work if that's what. Okay, use synthetic division to show x is a solution, which means you'll have a 0 remainder, and then factor the polynomial you'll get, list all solutions. Now, notice they're giving you x equals 2. They're not giving you x minus 2 or x plus 2. When they give you x plus or x minus, that's when you want to change the sign, but here they're just flat out giving you the number. So don't change the sign on that. Just make it 2 on the outside. Notice you're going to need a placeholder for a missing x squared. Pause the recording, give this a try, and resume to check your answer. Okay, so here we have the synthetic division. Like I said, you don't have a negative on the 2, it's just 2. You always do that when they give you the number instead of the factor. Bring the 1 down, multiply, 0 plus 2 is 2, multiply, negative 7 plus 4 is negative 3, multiply, and 6 minus 6 is 0. So it is indeed a factor. So we have x minus 2 times x squared plus 2x minus 3. Now factor x squared plus 2x minus 3. And we get x minus 2 times x plus 3 times x minus 1, which gives us factors of 2, negative 3, and 1. All right, let's try another one. Use synthetic division to show that x is a solution. Now, this one's a little tricky because you have 1 plus the square root of 3. So let me give you a hint. Anytime you have 1 plus the square root of something as a solution, 1 minus the square root is also going to be a solution. So pause the recording, give this a try, and resume to check your answer. So dividing in 1 plus the square root of 3, it's a little tricky. Bring down the 1, you get 1 plus the square root of 3. Now only combine the things that don't have the square roots together. It's kind of like combining like terms. So negative 3 plus 1 plus the square root of 3 gives you negative 2 plus the square root of 3. Now the next step is tricky because when you multiply negative 2 plus the square root of 3 times 1 plus the square root of 3, you must use FOIL. You must multiply that out. And when you do, you get 1 minus the square root of 3. When you subtract, you get, when you add, you get 1 minus the square root of 3. And again, you must FOIL those out. But when you do, you get negative 2, which has a remainder of 0. Now, like I said, anytime 1 plus a square root or something plus a square root is a solution, then the conjugate of that one or that number minus the square root must also be a solution. So we also need to divide 1 minus the square root of 3. So bring down the 1, multiply. Now this time it's easier. The first time you have to pull that out, it's really hard. But when you do the conjugate, it's just so much easier. And notice we're left with 1 and negative 1. So we have that x cubed minus 3x squared plus 2 is x minus 1 plus the square root of 3, x minus 1 minus the square root of 3, and then finally, very simply, x minus 1. So our zeros are 1, 1 minus the square root of 3, and 1 plus the square root of 3. In this example, you're going to verify the given factors, in other words, show that they work, find the remaining factors, write the complete factorization, list the zeros, and then graph. So what you're going to do is you're going to divide each of these into the polynomial, show that they work, and then find what's left. Pause the recording, give it a try, and resume to check your answer. All right, so we divide by 2 first, by negative 2, and we see we get a remainder of 0, which works. We divide by 1, we get a remainder of 0, and what's left is 2x minus 1. So we have x plus 2 times x minus 1 times 2x minus 1. Our zeros are 1/2, negative 2, and 1, and we can confirm that on the graph.